Your FastMCP server is running, but anyone can access it. How do you lock it down while still letting Anthropic's models call your tools securely? We'll implement JWT-based authentication in just a few lines, showing how to generate keys, verify tokens, and configure the server to require authorization without breaking the existing AI integration. From FastMCP, import FastMCP. From FastMCP server auth import JWT verifier. Auth equals JWT verifier. Public key equals key pair, public key. Audience equals dice server. MCP equals FastMCP. Name equals dice roller. Auth equals auth. This demonstrates the authentication wrapper pattern for securing RPC endpoints in a modular way. The code shows how to layer JWT verification onto an existing FastMCP server without modifying the core tool implementations, creating a clean separation between security concerns and business logic. What makes this distinctive is the declarative approach. Authentication becomes a server-level configuration rather than per tool boilerplate. The pattern works by injecting an authentication verifier into the server constructor, which then applies to all registered tools automatically. The JWT verifier handles token validation against a public key and audience claim, rejecting unauthorized requests before they reach your tool logic. This design follows the principle of cross-cutting concerns, where security is centralized rather than scattered across individual endpoints. This approach matters because it solves the common problem of authentication sprawl in RPC systems. Without it, you'd need to manually validate tokens in every tool function or build custom middleware. The trade-off is minimal. You add one configuration step during server setup, but gain consistent security across all endpoints. It's particularly valuable for AI integrations, where you need to expose tools to third-party services like Anthropic's API while maintaining control over access. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tools. It transforms Python functions into structured APIs that AI models can invoke directly, handling serialization, validation, and transport automatically. From FastMCP server auth import, JWT verifier. Imports JWT verifier, the authentication handler for FastMCP servers. This validates incoming JWT tokens, ensuring only authorized requests access your tools. Auth equals JWT verifier. This instantiates a JWT verifier for incoming requests. It validates tokens against the public key and ensures only authorized clients can access the MCP server, enforcing the audience claim of dice server. Public key equals key pair, public key. This passes the public key from our key pair to the JWT verifier. Public keys validate incoming tokens without exposing private keys, ensuring secure authentication while preventing impersonation attacks. This is the standard asymmetric crypto pattern for stateless auth. Audience equals dice server. This specifies the intended audience for JWT validation, restricting tokens to those explicitly issued for the dice server service. Prevents token reuse attacks by ensuring only tokens meant for this specific service will be accepted. This closing parenthesis terminates the FastMCP initialization block, finalizing the server connection with the configured authentication. Without it, the object creation would be incomplete, causing a syntax error. Always verify matching parentheses in nested initializations. MCP equals FastMCP. Name equals dice roller. Auth equals auth. instantiates the FastMCP server with JWT Authentication and a human-readable name. The auth parameter enforces secure tool access, while the name identifies this service in logs and the AI tool registry. This is the entry point for all AI callable tool definitions that follow. FastMCP JWT Authentication. The JWT verifier pattern shown here bridges Python functions and secure AI interactions, where tokens become both gatekeepers and translators between systems. Audience claims must exactly match between token issuance and verification, or authentication silently fails with 401 errors. This pattern scales from local testing with RSA key pair to production OAuth without changing your tool implementations.
The token that verifies nothing verifies everything.